everyone, I am Dr. Jagada Saravanan, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The discussion for topic is transformation of coordinate system. First, the definition of double integral. We are going to discuss about it. That is, here double integral, the capital R represents f of x comma y dr. That is, here the function in terms of x and y, they are defined. And we want to calculate the region in the two-dimensional, that is x and y. Otherwise, the same formula we can write in the way that is double integral capital R, that is f of the function x comma y, the region, the differentiation of region we want to calculate, that is dx dy, as it is double integral. That is, to calculate the area of a particular region using the double integral is, we are using the double integration. That's what it is called, double integral. Say it is in Cartesian form, then this is the formula to be used. Whereas it is in polar form, we will write to find the area of a particular region using this double integral f of r comma theta dr d theta. So this is now our innermost integration here from R1 to R2. Then the outermost integration is from A to B. So if it is in Cartesian form, this is the formula to be used. To calculate in polar form, we have to use it. But our topic is transformation of coordinate system. That is, the given is Cartesian form, we have to change into polar form and we have to find the region of the particular domain area. That's how to do it. Now, so from Cartesian to polar coordinates we are going to change, and this video lecture we are going to discuss about this. For that, x we are taking as r cos theta and y we are taking as r sin theta. So now to change completely the Cartesian form into polar form, so this we can notice it here, that is f of x comma y dx dy. To change into polar form, here this dx dy is multiplied by Jacobian. That formula using, we will convert into polar form. For that, we are assuming x equal to r cos theta, y equal to r sin theta. Now the Jacobian formula is dou of x comma y divided by dou of r comma theta. Now the determinant of, that is, the first row is dou x by dou r, next dou x by dou theta. So related to the x variable with respect to r and theta, we did the partial differentiation. The next one, the y variable, with respect to r and theta, we did the partial differentiation. Now, here dou x by dou r it is there. So x equal to r cos theta. So with respect to r, we are doing the partial differentiation. It is becoming 1. So x equal to cos theta. Next, dou x by dou theta. That is, this is with respect to theta we are going to do the differentiation. That is, the r is treated as constant. So cos differentiation is minus sine. So it is becoming minus sine theta. So the next one is, here we are noticing y equal to r sine theta. That is, here y with respect to r. So here r is the differentiation is 1. It is becoming sine theta, then dou y by dou theta. Here theta with respect to, we are going to do the differentiation. Then r is treated as constant. Sine theta, the differentiation is cos theta. It is becoming r cos theta. So the determinant we have to find. So the determinant, we know it, the rule. First we will multiply these two. We are getting r cos square theta minus, this is the minus related to the determinant finding formula. Then in the formula this negative sign is playing the role, and this two we will multiply. We are getting minus r sine square theta. So r cos square theta plus r sine square theta. So r we are taking as common out, then it is becoming cos square theta plus sine square theta. So here it is placed to the determinant. What we explained just now, it is written. Now this is the trigonometric identity. The value is 1. That is cos square theta plus sine square theta is equal to 1. So r equal to 1 r. So now, so this is in the Cartesian form. This x is taking r cos theta, y we assumed r sin theta. So dx dy it is changed into, to take the polar form, r into dr d theta. So the Cartesian, the problem if it is given in the form, to change into polar form, this is the formula to be used. So it is written here, f of r comma theta dA, that is the area to calculate. So f of r comma theta into r dr d theta. The innermost integration is defined for r as a function of theta. So that's what it is written, r equal to f1 of theta, r equal to f2 of theta. So it is then compulsory we have to do the innermost integration with respect to r. The outermost integration is for the limits for theta. Then finally the integration will be done with respect to theta. This is the procedure to be adopted from Cartesian form converting into polar form. We will take a problem that is evaluate. Here it is given the innermost integration is from 0 to infinity. The outermost also from 0 to infinity. So e power minus of x square plus y square dx dy by changing into polar coordinates. So looking at the question, first we will draw a diagram. That is, xy is there. It's a two-dimensional. So x-axis we have drawn it, and y-axis. So we are naming this horizontal line as x-axis and the vertical line as y-axis, and the origin is named as O. So related to that, the coordinate is 0, 0. As our given problem is in Cartesian form, there is a two-dimensional x and y directions. Next thing, our innermost one, that is the innermost integration, that is with respect to our x. From It starts from 0 to it goes on up to infinity it moves. That's what here the horizontal lines, the dotted lines throughout it is moving in the x direction up to infinity it moves. We can see the figure also. So the completely the dotted lines towards in the x direction up to infinity it moves. So it is up to infinity it moves. The innermost integration diagram this is. Now we will move to outermost one, how to draw. Even the outermost one also it is given 0 to infinity. What is the difference? The innermost one with respect to x direction, the outermost one with respect to y direction. So now, so we know it, this is our question. So the outermost one with respect to y, we have to draw the diagram. So x-axis, y-axis, x, y, the naming part is completed. We are concentrating now the outermost one figure. So origin O, the coordinate is O 0, 0. Now the outermost one with respect to y, our y direction is vertically. So that is the reason here from origin to the lines from where they are terminating, where they are ending. So they are ending up to infinity. So that is the reason here the vertical lines, if you are noticing in the figure, it is given up to infinity, they are moving. So the diagram which is given. So this is the diagram for our outermost integration. The previous slide we have seen innermost integration, that is drawing horizontal lines. This is outermost vertical lines, but the problem is put together double integration. So horizontal and vertical, both the lines we will mix and we will draw the diagram. So this is the question we have to keep always in our mind. So put together the complete question, the diagram, this is the one. As usual, x-axis, y-axis, origin, coordinate, that is 0, 0. So this is the diagram for our horizontal, that is x-axis. It moves up to infinity. Now this diagram, it is recently what we have come. Vertical, that is for our outermost one with our y direction. It should come inside y direction. Completely it moves. So the second one is with respect to y. So the diagram part we completed and we noticed it. So we can see it here. That is x and y. Yes. Now how to calculate this area of this region? The point is very clear to us. It moves up to infinity. Even y direction also up to infinity. To explain purpose, to some extent it is kept. That is horizontal lines. Actually to say, we can extend more. Here also we can extend because the limits are up to infinity in x direction also, in y direction also. How to calculate the area? And we have to convert this Cartesian form into polar form. So polar form, x and y, they are not playing a role. Radius and angle, they are playing a role. So we have to convert our Cartesian form into polar form. How to calculate here radius? For that purpose, this is the way we are calculating. That is, from this origin 0 to, it goes on. Our x direction is goes on, our y direction is goes on, even our radius also will be going on. Because x direction up to infinity, y direction is also up to infinity, even radius also up to infinity. So the radius calculation we completed. Angle. At this point, the angle is 0. That's what theta equal to 0. Next, from here, it is coming here touching. Because according to our question, complete our region. It falls in the first quadrant. It is not touching this area in the second quadrant and all. So the angle from 0 to pi by 2. So the radius we calculated, that is up to infinity. The theta also from 0 to 90 degree, pi by 2. So now this question is there, our question. According to that, the diagram, we have drawn it. So drawing the diagram, what is R? The radius from where to where we have to take, that is from 0 to infinity we have to take. The angle from 0 to pi by 2 we have to take. So that here it is written, the limits of x direction, that is from here to, it moves 0 to infinity, that is from the question what is given, we are writing in words. And what about y? The question from 0 to infinity it is given. So what is given in the question, in words we have written. The region of integration is the first quadrant. So after drawing, we are noticing our complete the region which falls in the first quadrant. That's what it is written here. We are putting x equal to r cos theta, y equal to r sin theta to change into polar form. That's what in the starting of the first slide we discussed it about this. So it is kept in the slide, every slide, that question. So this is the final diagram. Looking at this question, we got it. Now, so to calculate, so we have drawn a radius vector. That's what this is, the vector. Which starts from where? It starts from our origin. Where it ends, x direction up to infinity, y direction up to infinity, our radius also up to infinity. That's what here, the writing part it is done here. Now our radius limits, that is from origin to infinity, because here 0 to infinity, the radius, we converted our Cartesian to polar, that is x and y directions are converted into radius and angle. Now the theta, the starting the angle is 0, so it is touching the 90 degree and it terminates there. So the angle is from 0 to 90 degree. So the polar form of the given integral is, so the starting we can see it, the radius from 0 to infinity, the outer one is the theta from 0 to pi by 2, and our question is, we know it, this is e power minus of x square plus y square. That is, x we have taken r cos theta and the square is there. So r square cos square theta plus r square sin square theta. So put together r square of cos square theta plus sin square theta. So we are getting, this is a trigonometric identity, that is 1. So r square we are getting. That is the reason here the e is written as it is and minus also written as it is, whereas x square plus y square, just now we did the calculations, that is r square. This is dx dy, that is the Jacobian we did in the starting of the video lecture, that is r into dr d theta. This integration, double integration, we have to do it. So now this integration to do, we are going to adopt a simple technique. That is, this here, we added some terms. That is, minus 1 by 2 is there and minus 2 is there. So what I circled here, these are the changes are made before this step. Why suddenly we have taken minus 1 by 2 and minus 2? But mathematically it is correct. That is minus 2 multiplied, minus 2 divided. So there is mathematically there is no mistake at all, no wrong, because it is balancing. But the reason is why we have to do it, why suddenly we are introducing this multiply and divide by 2. So that is the question which is ringing in our mind. So now we can see it, a formula, this we are going to use it, that is e power f of r. This f of r, if we are doing f dash, that should be multiplied. Here, this part we have taken minus r square as f of r. Minus r square. F dash of r, it's nothing but minus 2r. So now we want it in this place, r place, we want it minus 2r, we want it. But minus 2 is missing. That is the reason multiply and divide by minus 2 it is done here. Now this complete thing, it is fit for to apply this formula. The formula is, if this condition of this integral formula is satisfied, we can write e power f of r. Our f of r is nothing but minus r square. So e power f of r, that is e power minus r square, that is the innermost integration we completed. Just we have to apply the limits. That is from 0 to infinity. This minus 1 by 2 is written outside as it is. So we didn't touch at all here. The minus 1 by 2 it is kept because anyway it is a constant. There is nowhere connected to this integral it is going to take part. Now, this we did the integration with respect to r, our innermost integration. So r place we are going to apply the upper limit value, that is infinity. So it is becoming e power minus infinity equal to 0. So we are substituting here 0. So upper limit is completed. This is the formula minus. and the lower limit is 1 because we are substituting the lower limit value 0, that is this r place we are substituting, it is becoming e power 0, the value is 1. So now this minus put together 1 by 2 integral 0 to pi by 2 d theta. Now we have to do the outermost integration. So here we started completely our innermost, we finished it and we got it d theta. The outermost, this we are going to concentrate. So now, so question it is kept in every slide. So 1 by 2 integral 0 to pi by 2 d theta. So the 1 by 2 it is written here d theta, that is the d theta, the integral is theta from 0 to pi by 2. So 1 by 2, the theta place upper limit we are substituting pi by 2. So now this is the limit formula and here we are substituting the lower limit, that is 0. So the final answer, we got it pi by 4. So we will come to a conclusion of this topic, transformation of coordinate system. The starting we discussed what is Cartesian form, what is polar form. If Cartesian is given, change into polar coordinates. This is the formula to be used and we have to keep it in our mind. dx, dy, they are changed into r dr d theta. This we should not forget because they are Jacobian. The formula is playing the role. That is also, it is discussed in this video lecture. And we have taken a problem, both x direction 0 to infinity and y direction also 0 to infinity. Each and every step they are animated with a figure. It is explained. So this is the final figure of this question. It is completely changed into polar form. So thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.